Hey everyone, it's Coach Latham, your math coach, getting you ready for the SOL test with a quick review of direct and inverse variation. As always, we're going to do this in 15 minutes or less. All right, you first take a look at these four graphs and ask yourself what's similar about each one of them. Well, the most obvious thing that's similar is that they're all straight lines. And the other thing that should become apparent upon a little bit closer inspection is that all four of these lines go through the origin. They all pass through the point 0, 0. That means that they are examples of direct variation. Right here I've got one example of direct variation. Again, you can see that this graph goes through the origin and is a straight line. A direct variation graph is one that is of the form y equals kx. So k is going to be a constant, and it's also going to be the slope of a line when you get it in graphed form. So we take a look at this line that I have on the board. It does go through the origin. That's the first requirement to be direct variation, and we need to find out what the constant k is. We go up 2 over 1, up 2 over 1, up 2 over 1. So for this one, the slope of the line is 2, which means that the constant of variation is also 2. Now let's talk about this in a little bit more detail. Let's say that you were working a job and you were getting paid $2 an hour. Firstly, you're getting ripped off. Everybody gets paid more than $2 an hour nowadays. But if you worked 1 hour, then you get paid $2. If you work 2 hours, you get paid $4. If you work 3 hours, you get paid $6, and so on. So this is what direct variation is. Y is equal to a constant times a number. If k is 2, x would be the number of hours you worked, and y would be the amount of money that you get paid. All right, graph the following two equations on the coordinate system. These are two examples of direct variation. They both are in the form y equals kx, y equals kx. Go ahead and hit pause and see if you can sketch these in your notebook. Okay, we're back. I'm going to go ahead and graph the red direct variation with my red marker. It is a direct variation. It goes through the origin, so I'm going to put a dot right here at the origin. It has a slope of 3/4, or in other words, k for this one is 3/4. So we're going to go up 3, 1, 2, 3, over 4, 1, 2, 3, 4. We're going to connect the dots. Hopefully I can make a line that's reasonably straight. And here is your red direct variation. We'll go ahead and do the same thing for the blue one. K for the blue one is going to be -3, which means that's going to be your slope. Since it's a direct variation, it goes through the origin. The slope is -3, which means we go down 3, 1, 2, 3, and over 1. Remember, when your slope is just an integer, it's always over 1. So here is that direct variation. So we have just successfully graphed two direct variations. Both of them go through the origin. Remember, if you ever get an equation and there's a number hanging out here on the end, like +3 or -2 or something like that, that's going to make it not a direct variation. What we're really saying is all direct variations have a y-intercept of 0, but we don't write +0, so it's just in the form y equals k. All right, which graph represents a direct variation? I'll give you 5 seconds to think about this. That's all it should take. The red graph represents a direct variation. They're both straight lines, but only one of them goes through the origin. So the red line is the one that represents a direct variation. Suppose y varies directly as x. All right, so it's a direct variation, so we know that this equation is going to be in the form y equals kx. And it says, and y is equal to 15 when x is 5. Y is equal to 15 when x is 5. So our equation is 15 is equal to k times 5. Find k. No problem. We'll find k. We just simply divide both sides by 5. And we get k is equal to 3. And then find the value of y when x is 30. All right, so now we know that our direct variation equation is y equals 3x. And now they're asking us to find a specific answer when x is 30. All right, so when x is 30, y is equal to 3 times 30, and 3 times 30 is 90. Okay, sometimes on the SOL test, they'll give you a couple of tables. Identify each of the following that is an example of direct variation, and what is the constant k for each one that is a direct variation. Hit pause and figure this question out. All right, we're back, and hopefully it was obvious to you that this one is direct variation. It goes through the origin. That's one of the requirements, so we have 0.00. The other one's going to be that we multiply by everything the same number every time. Start with the 1 right here. That's pretty easy to see. 1 times what is 3? Well, 1 times 3 is 3. So we think k is 3. Let's check it for the others. 2 times 3 is 6. 3 times 3 is 9. 0 times 3 is 0. That's a winner. We know that this is direct variation with k equals 3. This one on the right is not a direct variation. It does not pass through the origin. Furthermore, we don't multiply by the same thing each time. If you look right here, we know that 1 times 3 is 3, but 2 times 3 is 6, not 5. So this one cannot be direct variation for a couple of reasons. All right. Read these two to yourself and see which one you think would be a direct variation. All right, we're back, and the top one says that Juan is paid $200 per week, so let's say his pay is equal to $200 per week. In addition to that, Juan is paid $200 per week plus 15% of his sales, so plus 0.15 times his sales. This is not direct variation. It's not in the form y equals kx, so this one is not going to work. Let's take a look down here. Juan drives his car at a constant rate of 40 miles per hour, represent the distance. So Juan's distance is going to be equal to 40 miles per hour times the number of hours that he drives. This is direct variation. It is in the form y equals kx. And in this one, k is going to be equal to 40. If you do that one in your head, it kind of makes sense. If Juan drives 1 hour, he's gone 40 miles. If he drives 2 hours, he's gone 80 miles, and so on. All right, inverse variation is kind of like the counter of direct variation. And inverse variation, that's when you multiply two variables together and you get a constant. An example of inverse variation is right over here, where we have x, y is equal to 6. It's important to note that inverse variation is sometimes written in different ways. We could say xy equals 6 for that one. We could say that y is equal to 6 over x, because all I do is divide both sides by x to get y by itself. And we could say that x is going to be equal to 6 divided by y, because I divide both sides by y. So these three equations are all examples of the same inverse variation. Now, if you're confused in the least bit by that, go back and look at the video on rewriting equations, and that one should help. Write the inverse variation xy equals 6 in two other ways. What is k? Hit pause and work this out. Okay, we're back, and we start with xy equals 6, and we're asked to write this in two different ways. One way we could divide both sides by x, and that would give us, these x's cancel out, y equals 6 over x. In another way, we could divide both sides by y, and now the y's cancel out, and we get x is equal to 6 over y. So these three equations all mean the same thing, and of course k for all three of them, I don't know why I put a 3 there, k for all three of them is 6. All right, here's an example of a graph of inverse variation. That's not on your SOL test, but just to show you that it looks drastically different than direct variation. I've got two tables right here. Hit pause for a second and see if you can tell me which one is inverse variation. Okay, we're back. You should have selected the bottom one as inverse variation. It's inverse variation because x times y is always equal to a constant. 10 times 1 is 10. 5 times 2 is 10. 2 times 5 is 10. 1 times 10 is 10. So our constant is 10. Just to review, the top one was actually an example of direct variation. So you can see the two of them side by side. It goes through the origin, and you always multiply the x times the same number to get the y. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. So this is in the form y equals kx. That's direct variation, and k was 3 for this one. I didn't write the equation of the bottom one, but in each case, x times y was equal to 10 for the bottom one. So there's direct and inverse in a nutshell. All right, identify each of the following that is an example of inverse variation. What is the constant k for each one that is inverse variation? Take a minute, answer these questions. Okay, this one may be a bit confusing. The first example, m equals f over a, could have been an example of inverse variation if force were a constant, but force is not a constant in this problem. We don't have a constant in this problem, so there's no way that this one can be an inverse variation. The second one says Boyle's law states that for any gas, the pressure times the volume equals a constant. For a given gas, pressure times volume is equal to 2,000. So here's our equation. Is it in the form xy is equal to k? Yes, it is. And in this case, k is 2,000. So that's everything that you need to know about direct and inverse variation. Please see your teacher to get some practice problems as you prepare for the SOL test. Keep working hard. You can do this.